Welcome back. In this lesson, we're going to be talking about momentum. And momentum essentially has to do with inertia. If you recall that inertia is a resistance to change of an object. So if you have anything with a mass, anything at all, so a car or a bullet or even air, anything that's massive, it doesn't want to change the direction that it's going. It doesn't want to change the speed that it's going. So if it is stopped, a car wants to stay stopped. To accelerate that car, you have to put a force on it to make it accelerate. If that car is moving, to stop a moving car, you're going to have to put a force on it. So a force like a brick wall that it slides into, if it's moving, is going to cause a lot of damage. We're going to see that momentum has to do with the inertia of an object in motion, right? So if you have an object that's in motion, it wants to stay in motion. That object's inertia is based upon its mass. The more mass of an object, the harder it is to catch it. So it's harder to catch a bowling ball than it is to catch a ping pong ball. So to stop its motion would be harder the more massive it is. Momentum is just this idea of motion of inertia. So we're going to look at that today. We're going to look at some different ideas about it, and you will recognize, I think, that you do this all the time. Continuously, you want to change the motion of an object. You're going to have to do some tricks that has to do with momentum. So the mathematical formula of momentum is the mass times the velocity of an object. So a mass that has inertia because it has a mass times its velocity is going to give you the momentum that we're going to be talking about in a bit. So for instance, if you had a car and a truck and they were going the same speed, which would hurt your car the worst if you got into an accident with it? So if a car hit you at 5 miles an hour, it would do whatever damage that would do. If a truck that was much heavier than the car would hit you at 5 miles an hour, would it do more damage? Well, absolutely. I'm more scared of a truck than I am of a car. In fact, the reason why everyone wants a big SUV is because if they get into a small wreck, they want to win. They want to be the biggest in the wreck. They want to do the most damage on the other guy and have least damage done on them. And that has completely to do with momentum. So mass times velocity is momentum. So what would hurt worse? A truck going 5 miles an hour or a car going 50 miles an hour? Possibly the car. Do you see? Because that car's mass times its velocity is a higher number most likely than a truck times its velocity. It depends on what the weight is. So you're looking at two numbers. You're looking at its velocity and you're looking at its mass multiplied, and that product is called momentum. So see if this makes sense to you. A moving boulder has more momentum than a stone rolling at the same speed, okay? Because a boulder weighs more than the stone. So since it has more mass, it will have more momentum at the same speed. A fast boulder has more momentum than a slow boulder. So even though the masses are the same, if the speed is higher, you're going to get a higher momentum. A boulder at rest has no momentum, and that is what you must remember. The momentum is a product of mass times velocity. So even if you have a huge mass, if it's not moving, it has a zero velocity. 1,000,000 times zero is still zero. So something not moving has no momentum. Something that is moving does have a momentum. So for instance, if you were the captain of a battleship that weighed a ridiculous number of tons and you wanted to stop it, how fast could you stop it? Okay, if you're driving your car, your driver's manual will say, please stay at least 4 lanes behind the car in front of you. Why? Because if you stop, it's going to take a long time. Once you put on your brake, it takes a long time for that car to lose its velocity and have a momentum of zero. Okay, it's not going to change any of its mass, but the velocity will go down to zero and its momentum goes down to zero. And you want enough distance for that to work. So if you change your speed, you have changed your momentum. And so what changes velocity? If you want to go from, say, a low speed to a high speed, how do you do that? You have to add force. So changing momentum includes a force. If you want a momentum changed, you are going to have to add what is called an impulse. Different word, you've never used it in this idea before. An impulse is a force exerted on an object over a certain amount of time. Now, you may never have thought this before, may never have seen this idea before, but I promise you've used it a lot. So for instance, if you're going to jump off the bed, you don't keep your legs locked. You bend your legs because you want to stop yourself as slowly as you can. If you fall off the horse, you want to roll so that you will fall as long as possible. If you want to catch a ball, you will catch the ball and then move your arm back so that you're catching it as long as possible. Okay? If a glass falls out of your hand onto the floor, you would rather it fall on a carpet or a pillow than on the tile or the hardwood, because it's falling, once it's impacting longer. So the longer it can impact, it will not add as much force as maybe to crack the glass. It's possible that if you were to drop a glass on the carpet, it might not even break. But to drop it on the concrete, it probably would break. Okay? So if you do it backwards, let's say you want to increase the velocity of something, say a basketball or baseball, that's even better. If I want to throw a baseball, I don't just push my arm a short distance and then release the ball. I want the ball in my hand as long as possible. A coach would call this follow through. So you want the basketball to run off the tops of your fingertips. Why? So that it can stay in your hand as long as you can. You want it to be as long as possible. So if you want to change the velocity, which means you're changing the momentum of that basketball, you're not changing its mass, but the mass times velocity is momentum. If you want to change the momentum and get it to be accelerated, then you add a force over a certain amount of time, and the force times time is called impulse, and it is equal to the change in momentum. All right, so Ft equals delta mv. Okay, delta mv would be changing momentum. So I wanted to say go from stopped to a certain speed. Okay, and I'm not changing the mass of that ball. I have to add a force over a certain amount of time. And if I want the biggest force that I can do, then I want to exert it over the longest time. So follow through, there's no sport that you do not have follow through. You want to keep the bat in contact with the ball as long as you can when you're hitting it. When you're golfing, you want to have the club touch the ball as long as it can. Once it's gone, it's no longer exerting a force, but while it's touching it, it is exerting a force, and the bigger the impulse, the bigger the change in momentum, which means the bigger change in velocity. So as a review, you've got the force times time, which is called impulse, is equal to the change in mv, and mv is called momentum. So if I want to change the momentum of an object, I can't change the mass of this car, but if I push the car longer, let's say I exert a force on it, the longer I can exert the force, the greater the change in momentum. So think of pushing the merry-go-round, okay? You're pushing the merry-go-round. You want to push it as long as you can, as hard as you can, to get it to accelerate, okay? Because you're not going to change the mass of the merry-go-round, but you can change the velocity. So if you just give it a shove, boom, okay, it might go around a little, but if you give it a shove and continue shoving while you're running, you can get it going a lot. And that's the idea of an impulse. It changes momentum. So this should be review. If you want to follow through, then you can start an object that is at rest into motion. If you want it to go as much as possible, then you want to hit it as hard as you can, that's your force, as long as you can, that's your follow through. Okay? If you want to strike when you're playing bowling, you want the biggest ball you can move with your arm, and you want that changed. You're pushing that ball as long as you can before it leaves your hand. Just like trying to accelerate an object from rest up to a speed, I can decelerate an object and it changes the force for a second. For instance, if you want to catch a ball, you don't just hold your arms outright and then grab the ball, because that full force of that ball is now into your arm and it can hurt you. So you would step back as you're catching a ball, or you pull your arm back as you catch the ball, because you want to catch it over the longest period of time that you can. Just like you wanted to launch it over the longest period of time. So a football player that's throwing a pass wants to keep his fingers on the ball as long as he can while his arm is moving. Your arm is accelerating that ball, and while you're touching it with your hand, you're putting force on it. As soon as it leaves your hand, you're no longer putting a force. So the longer it can be in your hand while you're accelerating your arm, the faster the ball will move. Well, exactly the same. If you're catching a football, okay, let's say you catch it not on your chest, but you catch it in your arms, you grab forward and then you pull back so that you're catching it as long as you can. So if I want the force to be expanded, if you want the force to be bigger, you exert the force over a time, because impulse is a formula of product. It is time times force. Okay, so if you don't want the force of that to hurt you, say catching a baseball, you want to catch it as long as you can. So if you want to jump off the bed, you want to bend your legs so that you're hitting the ground as long as you can. So as your legs are contracting, it will absorb that force, will absorb the shock. If you want it to hope that the glass doesn't break, dropping it on a pillow will make that impact longer. So the impact longer will reduce that velocity, which means you're changing momentum. You're changing it from fast to zero, and the longer you can do it, the greater the change in momentum will be. Here's a cool example. You've got on one side momentum. Momentum is mass times velocity. So here's a truck. It's got a great mass, but it also has a fast velocity. So let's say that's a high momentum. It hits the hay. How long is it before it stops? Okay, as it hits the hay, it's moving through the hay, but the hay is slowing it down. So the time is great, and that means that the force doesn't have to be as great. The force on that truck is not great. It was kind of a wreck, but it didn't destroy the truck. If you have a very short time, say the bottom one, where the truck is hitting a brick wall, it stops in a very short time, so you're stopping it in a short time, then you have to have a huge force to stop that momentum, all right? So let's say that you're in an amusement park and you want one of these rides that go from 0 to 60 in 1 second, all right? If you want to change the momentum of that car that you're riding from 0, which is no momentum at all, to a very high momentum, which is whatever you weigh times its speed, then you need to have a huge force, a huge launching force, okay? Otherwise, you can still go to that speed in a long time and not need as much force. My car can go from 0 to 60, okay? It may not go as fast as your car. Your car could exert a huge force on it in a short time and change its momentum. My car can exert a small force over a long time and change the momentum exactly the same. My car costs less because the longer it takes to change that momentum, people are willing to pay less for it. So if someone's going to hit you in a boxing match, you don't put your head into it, you put your head away from it. As you move your head away from it, you're taking that impact longer, which as you increase the time, you decrease the force, and that force doesn't hurt you as much. If you are shortening the time by jumping into the punch, well, that's stupid, because you are shortening the time, you're increasing the force, and the impact on your face is worse. If you've ever tried to break boards or blocks in a karate class, usually you do not ask the beginner karate kids to do this, okay? Because the trick is to bring your arm down with as much speed as you can, but impact the blocks or the boards as short a time as you can. All right? The longer that your hand is pressing on the blocks, the less force will happen. The shorter the time, the greater the force. So if your arm has momentum because it has mass and speed, okay, your arm weighs something and it's going at a certain speed. So if you crash it down really fast and then impact the blocks very, very short, then all of that momentum is converted into force, and that force may be enough to break the blocks. The longer you hit it, okay, the longer your hit actually takes, the less force is going into that board, and all you're going to get is a bruise. The last I want to mention is bouncing, all right? So this is a great example. I'm going to just use this one instead of mine. If a flower pot falls off of the shelf and you catch it, all right? Normally you have your hands up and then you'll drop your hands lower and slow that pot down so that its change in momentum takes time. The longer the time that that you catch it, the shorter the force is, and you probably won't break it, okay? Well, if you want to send it back, so it's falling onto your hands, now you want to send it back, it's going to take all the force that you have to change its momentum down to zero, and then you have to change the direction and then speed it up again. So if something bounces, it has to have more impulse than if it just hits. So if a flower pot falls off the shelf and hits you in the head, there's a certain amount of damage. But if it bounces off of your head, then what's happened is you've changed its velocity once by stopping at zero, and now changed it twice by accelerating it back up into the air. That's more damage on your head. If you hit a lamppost in the parking lot and your car comes to a stop, okay, that's a certain amount of damage done to your car by the pole. But if you bounce it off of it, come forward and then bounce off of it, way more damage has done because you've had to stop it to zero and then accelerate it in the other direction. That car was going forward at a certain speed, it stops down to zero and then bounces and comes back. That means it had to be accelerated backwards. That takes way more force, okay? So bouncing, generally, there's a greater impulse to bounce an object than to simply stop an object. Here's the last example. A Pelton wheel is a mining wheel. So when the water hits it, it doesn't just stop it, but it actually turns it in a circle and makes it go backwards and essentially bounces the water. And when you bounce the water off of the wheel, you can turn a wheel with less rush of water. So let's say you don't have a huge waterfall, but you have more of a trickle. If you can send that water out, you can move the wheel around even with less force, because you're getting more out of a bounce than you are out of a stop.